All right, ladies and gentlemen, here we go. Talking about parallel and perpendicular lines today when it comes to linear equations. There is two main ideas you have to pick up from these things. Let's just take a look at these lines over here. If I asked you to tell me what the slope of these two lines were, if in fact you found the slope of those two lines, this won't take very long because I think it's pretty obvious. Maybe to me more than you, maybe to you more than me. Where did the lines go? Look, Russ. Chase, where did the lines go? Where did the lines go, by the way? And Keel Fisher, what happened to ICHS last night?
Well, we're up by 12.
Are you going to blame the referee?
Yes.
Okay.
He says he's gonna blame the ref.
Yeah, I can't do it. There was a lot of fun.
Anyways, back to the real important stuff here. If you're making a triangle out of this thing here, what is the slope of this line right here? It goes up 1 over 1, 2, 3, 4. Are you with me? This has a positive 1/4 slope. Yes, Mr. Hahn?
Yes.
This one here, if you put a dot here and a dot here and make that right triangle, guess what you get? The triangle is 1 over 4. Now, can anybody make the deductive leap without having to do the other two that are listed on here? That if this statement is true, parallel lines have, somebody out there? Thank you, who said that? Thank you, so, that's on that same slope. Now notice, then, it doesn't say they have the same y-intercept. Wait, Fish, what did you say happened to the ICHS game? I think they were ahead of 11 and a half.
Yeah.
What, did they go fall flat? It sounded like, from Mr. Jim Teckenbrock on the radio, it sounded like Fenger, was shooting like crazy though.
They started making some really absurd shots. And then we kind of took some bad shots and we kept turning the ball over, which resulted in them getting to a 4-point lead.
And then it went to 15 points or 12 points or whatever.
Then they just held the ball for basically the whole second.
Well, that's what happens. That's basketball. So back to this thing here. Notice the y-intercepts are the same, but the slope. Or the y-intercepts are different, but the slope or the slope is both the same. So that's all you have to know about that. Now, for the real interesting one, ladies and gentlemen, the second 3 graphs. Maybe you can guess what the second 3 graphs. Anybody want to speculate? Perpendicular lines. Come on, people. You're illustrations.
Oh, those are both.
They have different slope. Thank you, but there is a relationship between. Maybe somebody said something, but I don't think it was. So, you got something on this one?
Oh, they have differences?
Yes, they do, but can we go with how exactly different it is?
By 1. By whatever they're one.
So, let's look at the slopes of these. Hopefully my triangles work out here. Let's look at the slope of this line. It crosses here, and I say it crosses there. So I draw this triangle. Those of you that are close. How high is that triangle? 1, 2, 3, 4, 5, 6 high. Oh, over what? 2. I should have probably done a smaller triangle, which is what slope? Anybody? 6 over 2? 8th grade math? 3. Or 3 over 1 slope, right? Positive 3 over 1 slope. How about this triangle? I put a dot here and I put a dot here. Make this, here's my triangle. What's that?
1 over 4.
I'm sorry, what?
1 over 4.
I'm sorry, what?
1 over 4.
I'm sorry, what?
1 over 4.
Joseph, louder.
1 over 3.
Right, because this is only 3 line. 1, 2, 3. And what type of slope, positive or negative? Negative, going downhill. There you go, there's your slopes. Think about that. Fish, how many points did Caleb have, or Elijah have?
He had it was
Alright, enough of that. Oh wait, where'd it go? Let's do another one, because I don't think you made the connection just yet, did you?
Yeah, there's no opposite.
Wait.
How do you know what's negative and positive?
We gotta do one more, because I think somebody almost said it, but I'm not so sure they said it. Oh, wait, I might be hearing it there. This one here, I think it was probably supposed to cross here and probably supposed to cross there. So that made it 4/2, so positive 2 slope. This one here at a right angle. Oh look, I can make this little triangle there, which is 1/2, negative slope. So jumping on board there, ladies and gentlemen, what are you going to write for perpendicular lines? Perpendicular lines have, somebody said it? Opposite what though? Opposite just means one's positive, one's negative.
Opposite slopes.
Not opposite slopes, but
Signs? No.
opposite, somebody said it before. It's the big R word that we learned back in school. They have opposite reciprocal slope. Opposite meaning one's positive, one's negative. Reciprocal means you take the fraction and you flip it over. Now, what does that mean to you?
What does that mean to us?
I don't know. Let's look and see what it comes in the book. Here is, right, well, here's one right out of the book. Based on what you know now, I think you can probably do this problem. But I'll see. Letter B from page 426 if you're keeping track at home. Write an equation in slope-intercept form that passes through -3, 2 and is parallel to this might be a little deeper thinking than most of you are capable of, but we're going to give it a shot. The line with the equation just kidding for those of you listening at home. Y equals 4/7 x plus 1/5. 4/7 x or x plus what? 5/7. Can anybody sort out this gobbledygook and figure out what they're actually asking you? In slope-intercept form. Andrew, without asking your dad, do you think that you can figure out what they're asking for? First of all, I'm looking for a slope-intercept equation, right? What has this equation have to be? It has to go through this point. So if I was, you don't have to do this. I'm just telling you that this is what this is. -3, 2. But it has to be parallel to this line right there. So based on what you know, Aaron Murray, parallel lines have what? The same slope. So I know that the line, the equation I'm going to use has to have this same slope as that line. So I know y equals 4/7 x, but it has to also cross through that point. So how am I going to figure out where it crosses the y-axis? Ooh. Did you say you don't? I will entertain any knowledge. We will sit here until PE is completely over if I can't get somebody to give me a wild guess. I would have thought one thing would be completely obvious, first of all. Joseph, you usually have something. Chase, what? Emma?
Do you like go up from that point like a quarter?
Now that would be one thing that I would think most of you would have said. Well, you know that this is the point and you know that this is the slope, so I could go down 4/7 or up 4/7. I guess I can go up 4/7, can't I?
Yes.
1, 2, 3, 4, 1, 2, 3, 4, 5, 6. I know this is about roughly what my line looks like, but how do I really know what that point is? First of all, I didn't do it like on a piece of paper, so that might be kind of goofy. I will say no. That was what I thought you would have said. So that was a good answer because that's actually if you did an exact line, that would be it. Somebody else? Anybody? Somebody's thinking it out there. They just don't want to say it. So.
You start with like a -3, and you do the 5, 7.
Huh? 5/7 has nothing to do with the problem anymore. It's a whole different line, doesn't cross. This, by the way, this line crossed at 5/7, which would be somewhere, here's 1, 5/7 is somewhere around there. So you know the line looked like this, but that's not, that's the old line. Aaron Murray, save us. Huh? Say again? Oh, it's not. Unfortunately, it's not 2. Did you say, could I just say it's 2? No, you can't just say it's 2 because actually 2 would be right here. It's higher than 2, I believe. But you're close. Somebody? Aaron's like on the right track. Chase, I know you're thinking it. What information have we not even used? Pretend I didn't have a graph of this at all. What tidbit of information do I have that I haven't really used at all? I already used this part. What haven't I used? Autumn?
-3, 2.
Yeah, what do you suppose? How can this help you out? Chase? What formula am I using it for? What's that? I want to know what. So, here, I'm going to give you this. Look. Y, I know that. Y equals 4x plus b. That's what I know so far, and I need to figure out what b is. How can I figure out what b is? Most of you are thinking you just didn't say it. Madison?
You put the numbers in for y and x.
Yeah, this is an x value, and this is a y value. You just put those numbers in. 2 in for y, because it's the y value. -3 in for x. And what are you going to be left with when you do that? A little b all by itself. Let's do that. I can tell you're very excited about that.
Yeah.
Almost excited as you're going to be about playing crate ball for PE.
I know what it is. It's actually 2. Didn't you say that? Not -3. It's 2.
Oh, Joseph, see, I was so excited about crate ball. Wait, how do you know what it is?
The 2 is log for y.
Oh, I meant crate ball. Let's get into the real stuff here, Joseph. No, 2 is the y. 2 does equal 4/7 times my -3. So you could have never even come up with this had you not done it equation-wise. Plus b. What is 3 times 4/7? -12/7, right? And that equals 2. How do I solve this for b, ladies and gentlemen? Oh, come on, help me out here. Give me at least this far. Cassie Malis, if I have 2 equals -12/7 plus b, how do I get b by itself? And what happens when you subtract a negative? You are, thank you very much, you do the opposite, add 12/7. And then, using all of the 8th grade math you know, how do I add 12/7 to 2, Connor Morgan?
No.
I have to
Make it
add
multiply.
12/7 to 2. 2 is how many 7s? Somebody. How many 7s is 2? Thank you. 14/7 plus 12/7 is 26/7. And there is your b. What? That's not right?
Wait. So you add the 2 together and then you add it to it again? What? Okay, so you make it so.
what did I say, was it 12 sevenths?
12 sevenths.
12 sevenths plus 2 over 1. I just left that as an improper fraction. Common denominator would be 7. This stays 12 sevenths. 1 times 7 is 7. 2 times 7 is 14 sevenths. 14 sevenths and 12 sevenths is 26 sevenths. As a mixed number, that would be, what, 3 and 5 sevenths. Right? Which, if you go back to my graph, that probably was actually relatively close, right? 1, 2, 3, and almost up to 4. Not saying that was perfect on that, but it was pretty close. I was not perfect. I thought I was wrong once though, but I was wrong.
I get it.
We haven't played great golf?
So that's the answer is.
Oh, I'm sorry. And Madison got back to math. I missed all of that. Yeah, they wanted the equation. That's really where we should be. So the equation is this, Madison. Y equals, it's the same slope, 4 sevenths x, and we just figured out this to be our y-intercept. So plus 26 over 7.
Got it. 27.
I don't know. I really lost track a long time ago.
I'm too busy about great ball.
I wonder if that's what the answer is.
Something for your.
Do you think I got that right?
You know me.
Mr. Hahn, that looks very good.
Should I give you one and see if?
Please, no.
I wish letter C was not a 50-50 question. Otherwise, I'd give you that.
See, thank you, see. I see it.
All right. Now that we've discussed that,
There's still more.
now that you have this knowledge, I will do this. You have exactly 9 minutes. Well, I'm going to give you 5 minutes. This will depend on how much homework we get. Look at practice letter D.
Wait.
Practice letter D on page 427.
Oh,
I
see
am
it.
going to let you at your table, once again, the people at your table grouping, work if, let's see, for every table grouping that gets it right, let's see, there are really 30 problems here. I will take away 70. I will take away 3. 3 problems for every table grouping that gets it right. I've given you all the knowledge you need based on this. Wait, the only difference is 8th grade, you're not looking for parallel lines this time, you're looking for perpendicular
Wait,
lines.
so how would that change?
It's
I
automatic.
don't know what's the difference between parallel lines and perpendicular lines.
Well, we got the notes right here.
Go!